ഇല്ല ഇല്ല അയച്ചിട്ടില്ല അയക്കണം. A very good evening, everyone. We'll start today's class. Yeah, uh, we are presently looking into the reaction mechanism analysis to predict the mechanism of a reaction that's happening. And yeah, that's what we are actually doing in this class. Yeah, so we started last week with that. So where we saw a simple step reaction where the electrode undergoes dissolution and it's directly going into the electrolyte. So it was a single step. Then we moved on with the reaction mechanism, which is involving at least one intermediate. So that is what was covered in the last class. So where you'll have one reaction intermediate involved. So when reaction intermediate is involved, you should take into consideration the fraction of sites that are actually covered by that intermediate, and that's how we proceed. So in this week's course, we had actually seen when there are two reaction intermediates that are involved, how to do the problem. And another aspect we saw was when impurities are single step reaction with the first case we studied, along with the presence of any intermediate. If anything is present, how will it behave? So that was what was seen in this particular class week. So now we can start solving some of the reaction mechanisms. So before going through the revision for this week's course, I would like to discuss the problem that we had stopped last week. I just gave some hint like how to do about in that, and I had made a small mistake in that. So I wanted to solve that entire problem once again, and then we'll move on with this week's course. Yeah, I hope my slides are visible. Okay, I haven't shared it. So yeah, I'm sharing my slides, and yes, we'll start with the. Yeah, so we'll see what we had seen in the last class, and then we will go with this one. So the reaction was something of the form. There is a metal which was given an something like M adsorbate. So this is one intermediate that is involved, and during this process, it's a electrochemical process. And in the next step, it is this M adsorb that is forming M solution. So you can see there are no electrons involved in the second step. So I can consider that as a chemical step. So I had distinguished in the last class what is an electrochemical step. The reactions involve transfer of electron, and one without the transfer of electron, I can term it as chemical reaction. And when I'm calculating the Faraday current, I will consider only those reactions which involve an electron transfer. And in the final step, it is the metal also forming the M solution. Metal can directly can dissolve into the solution without the formation of an intermediate. So that is what is the step 3. Okay. So this was where we stopped last class. I wanted to discuss this because I had made mistake. Okay. So as you all know, so if anyone is interested, what's first thing that we do? Can anyone tell? Anyone who knows? So how do we proceed? So basically for any thing, we'll have to find out the side balance equation, and you'll have to find out the Faraday current. So these are the two things. So for this reaction, if I'm writing the site balance, the total number of site is gamma, and it's d theta by dt. So as we have only one reaction intermediate involved, I can write it directly as theta. If multiple were involved, you will have to write separate equation for each of the intermediate involved. So yeah, So the mistake I had made was in this step. So how do you do the balance for the intermediates involved? So in the first step, you can say it is nothing but this K1 into theta. Sorry. So in the first step, so I told theta is the fraction of sites that are occupied by the m absorbed. So for the
1
first
minus
step,
theta.
yes, k1 into 1 minus theta, which corresponds to that of the first reaction, correct. So yes, so the next step involves the consumption of m adsorbed. The second step, m adsorbed is getting consumed. So actually the sites are reducing. So that's why you'll do minus k2 into theta. So last class
Theta.
I wrote again plus k3 into theta, which was wrong. So I made a mistake. So what we are actually doing is a side balance. So side balance of what? Theta. Theta is corresponding to m adsorbed. So you will consider only those reactions in which m adsorbed are involved. So in the first step, the m adsorbed is formed, and the second step, m adsorbed is getting consumed, right? So it will be nothing but k1 into 1 minus theta minus k2 into theta. This step does not involve any formation or consumption of the m adsorbed. So in the theta balance, you do not have to consider that step. So theta step, the balance, in the side balance, you will be considering only those steps in which the intermediate formation or consumption is happening. So this is the first step. I hope that is clear. Now, the next one is obviously I have to do this at steady state. Okay, at steady state, what will be the site involved? So that to find out, so steady state corresponds to no to the DC current. So it will be nothing but I'll be equating the above equation to 0. So that means K1 DC 1 minus theta SS minus K2 DC theta SS equal to 0. So now you have to find out theta SS. So what you can do is you can separate those terms with theta SS on one side and the constants on the other side. So if you are rearranging this, you will get nothing but you'll have K1 DC. So I'm taking all those terms with theta SS to the other side. So that you will get as K1 DC. Okay, again I made a small mistake. Uh, Yeah, so you know that the second step is already a chemical step. There are no electron transfer involved. So that means when no electrons are transformed, the rate constant will not be a function of potential. In fact, it will be a constant. It has no effect of the potential applied. So you can directly write it as minus K2. So please be careful with all these small things. So yeah, I hope that point is clear. Anyone has any doubt, you can ask me. So you'll get something of this form. And if I'm rearranging it, I get theta steady state as K1 DC by K1 DC plus K2. So this is the equation for the theta axis. So now what? Now the next step is to find out the current. So first we will find out what is the current in steady state. Okay? Who can tell the formula? Anyone can tell what is the what to say, the Faraday current and DC current. I mean when DC Faraday current. So The Faraday current is nothing but it is N into Faraday constant
F. Yes.
into rate. So rate will be nothing but will be considering only those steps in which an electrochemical reactions are happening. So in this case, the first one and the third one are the only steps in which the electrochemical reactions are involved. So here you can see only one electron is involved and n value will be that's why 1. Now F into rate. So F into rates. What is the rate of the first step? The rate of the first step is nothing but it will be K1. So we are talking about the DC current. So it will be nothing but K1 DC into 1 minus theta. So because it's a steady state, I can write it as theta SS plus, if you see it is K3 DC, right? K3 DC into 1 minus theta SS. Because it's again M. So it is nothing but K3 DC into 1 minus theta SS, right? So if you see both 1 minus theta SS are common. So I am taking 1 minus theta SS outside. Into K1 DC plus K3 DC. Who can tell what's the final expression? Did anyone try this? I had given last time. Anyone can tell what's the final answer? Anyone? So what is theta SS? Theta SS is K1 DC by K1 DC plus K2. So if I substitute there, what will I get? I'm just cross multiplying 1 minus theta SS. So I'll get something like K1 DC plus K2 minus K1 DC. Right, what did I do is 1 minus theta SS. So I did not write that step. I'm directly cross multiplying it. Okay. K1 DC plus K2 into, so this will both get cancelled, K1 DC into this into K1 DC plus K3 DC. Right? Any doubt in this? Anyone has any doubt?
No, it's okay.
Yeah, so finally you will get IFDCS. So basically, the issue, I mean, it is tried the like that. The major part is just to identify what will be the theta balance. I mean, which all equation you have to take and which are to be omitted. So if if you're able to get that equation correctly, then it's all about solving it. Okay. DC plus K2, K1 DC into K plus K3 DC. right? So this about that. Now the next one is to find out IFAC. That is when AC, what is the Faraday current when you are applying an AC current also. So the equation remains the same, right? What is it? F into K1 into 1 minus theta plus K3 into 1 minus theta. Now, who can tell me how will we, what to say, uh, elaborate and write K1 and K3 when AC current is applied? How will it depend upon the potential? Let's see in the linearization. Can anyone tell me what will be the equation after linearization? So K1 will be nothing but it will be K1 DC into these equations do not change. You will have to apply the same thing. So it's all about same equation, only your first few set of equations will change, and after that you have to substitute it and find it. It's K1 like this, and K3 will be nothing but 1 plus B3 EAC. So yeah, this will be one of the substitutions that you apply, and the next thing will be theta. Theta also we had truncated and found out that theta will be nothing but theta SS plus theta dash EAC. So can everyone substitute and tell how will the equation be? Please start doing. I'll give you few minutes and then I'll start doing this. You have to basically substitute all these three equations into this, and you have to simplify. So then you get the equation. In order to find out IFAC, sorry again I've done a mistake. See, it's not IFAC, this is the IF total. So basically you will be then separating out what to say IFAC and IFDC separately, and that's how you get IFAC. Please try doing it. I'll give a couple of minutes and then I'll start doing this. Anyone has any answer? Okay, I'll also start doing. So here in this case, it will be nothing but what I have to do. I have to substitute everything. So first thing what I'll do is I'll take out k1 and k3. 1 minus theta is common. So I can take out 1 minus theta and I get something in the form k1 plus k3. Now I'm substituting all this. Minus theta dash EAC. Now into k1 plus k3. So if I elaborate it, I'll get this as k1 dc plus, that is k1 plus k3. So I'm just elaborating k1. K1 is nothing but k1 dc into 1 plus b1 EAC. So I'm just elaborating that and writing k1 dc plus k1 dc b1 EAC. Okay. And same way I can write for a similar way I can write for k3 as k3 dc into 1 plus k3, sorry, 1 plus b3 EAC. So same thing, I am elaborating that term also. I'll get k3 dc plus k3 dc b3 EAC. Now I'm gonna cross multiply. So it will be nothing but f into 1 minus theta ss, and I'll multiply that by k1 dc and k3 dc are the constants. So I'm just simplifying it by reducing the number of steps. Okay, k1 dc plus k3 dc. Similarly, this one minus theta dash EAC. Okay, into k1 dc plus k3 dc. I'm just taking out those terms in which only constants are involved inside the second bracket, k1 dc plus k3 dc. Now what I'll do is other terms inside that second bracket will be multiplied by those in the first bracket. That means k1 dc b1 EAC and k3 dc b3 EAC will be multiplied by 1 minus theta ss. Any doubt in this? Any doubt? Okay. So anyway, I'll continue it. So yeah. So 1 minus theta ss is multiplied by other terms which are involving EAC in the terms. Okay. Now, can I multiply minus theta? Yeah, I can multiply theta dash EAC into all these terms. What will happen? EAC into EAC, EAC square. So already that value is something in the range of millivolts. So again, if you square it, it's going to be even more smaller value. So you can actually neglect that. So finally, the equation will have only these many terms. So now we already saw kf into k1 here. You can see this step. Okay. F into k1 dc into 1 minus theta ss plus k3 dc into 1 minus theta ss. So same thing is written here. So this term is corresponding to IF dc. right? So this is what, I mean the rest of this is what corresponds to IFAC. So I'm again rewriting it as IFAC equal to F minus theta dash into K1 dc plus K3 dc. Okay, and EAC I'll take it out at the end. I'll keep plus 1 minus theta SS K1 dc B1 plus K3 dc B3. Right, into EAC. So this IF by EAC is nothing but it is 1 by Z, that is 1 by impedance, or it is equal to admittance. So this value is nothing but 1 by Z. Okay. So now what are the unknowns in that equation you need to get, right? You should get it in terms of the, what to say, the constants. So here theta dash is something unknown. Now how to find out theta dash? So that we already saw. So where we saw that d theta by dt is nothing but equal
Excuse
to,
me, ma'am.
yes, tell me.
You have just now told that this IFAC, that is 1 minus theta SS into K1 DC plus K3 DC. So that term is, where is gone? Where is that term?
Yeah, so that is corresponding to IFDC, right?
Yes, IFDC. Right.
So what I want to find out is IFAC, due to AC current, what is the Faraday impedance?
Right.
So from that, so if this is corresponding to DC current, I mean this is what is corresponding to IFAC, the second term and the third term. So we already know impedance is nothing but is Z by, so EAC by IFAC. That is what is impedance. So basically, Faraday impedance is nothing but EAC by IAC. So I have to find out IAC. So that is why I am omitting the terms which is due to IFDC.
Right.
Okay, so I've already found out in the previous, I mean the first thing we do is we find out IFDC. So that we already know this one. This is the equation. The rest is simplification of that. So I'm just
Right.
removing that, and the rest corresponds to IFAC. Okay. Yeah. So now the next thing is the only unknown in that equation is theta dash, right? So theta dash also has to be found out. So we already know, we have already in the previous class we saw how that equation comes. D theta by dt is nothing but it's nothing but j omega EAC theta dash. So this is the equation. So how do we find out? We have to go to the first equation, that is gamma into d theta by dt equal to k1 into 1 minus theta minus k2 into theta. So in that, if I substitute, it will be gamma into j omega EAC into theta dash equal to K1 into, so again K1 will be written in terms of K1 dc 1 minus theta ss, sorry. So K1 dc into, again we should write that also in this expanded form, K into 1 plus B1 EAC into 1 minus theta, which is nothing but 1 minus theta ss minus theta dash into EAC minus K2 theta. So we already know K2 is a constant because it is not a electrochemical step. So minus K2 into theta. Again theta can be written as theta ss plus theta dash EAC. So all the terms except those with EAC in it will be neglected. So we need both the sides to be balanced. That means only those terms with EAC will be considered. Constants will be neglected. EAC square will also be neglected. So I am taking only those terms. So how do I get that? It will be nothing but K1 dc. I am multiplying that with 1 minus theta ss. That's the first term, right? K1 dc into 1 into 1 minus theta ss. Next term will be K1 dc into 1 into minus theta dash EAC. Now what will be the next one? Again K1 dc B1 into B1 E1 AC, B1 EAC into 1 minus theta ss. Any doubt in what is being written? Basically, I'm just opening the brackets, and then last term K1 dc B1 EAC into minus theta dash EAC. You'll see EAC square will come, so that term is going to be very small and we can neglect it. Now in the next one, if I open the brackets for this one, it will be nothing but minus K2 theta ss minus K2 theta dash EAC. So as mentioned, all the terms, all the constants will be neglected. So this one is a constant, yeah, and this one is also constant. Now, what do? We see this side also. So it's gamma, j omega, EAC, theta dash. So all the other terms, all are having EAC terms will be considered. Again, EAC can be neglected. I mean, all are the terms with EAC. So we are taking the coefficients. Now what can we do? We can take the terms with theta dash to the other side. That is this terms K1 dc theta dash, K2 theta dash to the other side. What will be left on this side will be K1 dc B1 1 minus theta ss. So finally, if I am writing, theta dash will be nothing but K1 dc into B1 into 1 minus theta ss by gamma j omega plus, so here it will be K1 dc plus K2. Are you getting similar equation? Did anyone try? Did anyone try? Okay, so what is the, yeah, tell
In
me.
between, there was a voice interruption. Means, so I couldn't understand that how you have cancelled this minus K2 theta SS and this A1 DC 1 minus theta SS. What is the
Oh, okay. So here
couldn't
it is like this is the entire equation, right? Gamma j omega AC theta dash into equal to all this. So we are equating those terms which are which are coefficients of EAC. So basically, if I write something of the term phi x square plus something like 6 or something, and you're asked to find out might be ax square plus 6. What is the value of a over here?
5?
Yeah, same thing we are doing. So here instead of x it is EAC. That's the difference. Are you getting? So EAC, like we are equating the coefficients of EAC and trying to find out what is the value of theta dash. So if both sides should be equal, there shouldn't be any constants. Okay, if LHS should be equal to RHS, so here you only have a term with this thing. So basically there is no 6 over here, and here also that means I shouldn't have anything, only then I can say both are equal, right? If this so same thing we are doing. We are equating only those terms which are having EAC on either side. So for that they are saying there are no constants, those values should be equal to 0. And once we equate it, we find out theta dash will be nothing but will be K1 DC into B1 into 1 minus theta SS by gamma j omega plus K1 DC plus K2. Now what you have to do? You have to substitute back yeah, so here you have the theta dash and you have to substitute back this one. So if you see, all these are a constant, right? All these terms of z is a constant, and here you will have this one will be what will be a function of omega. So if I am doing the Faraday impedance, I can get something of the form like this. So where this part will be represented by this, and this theta dash is a function of omega, we already found out, and this entire combination can be represented by a resistor and a capacitor in parallel. Okay, so this is how we are doing this problem. Any doubt, anyone? Anyone is having any doubt? So otherwise we'll move to the next problem that is based on this treats. So the next one is so the next one is electron transfer plus electron adsorption reaction. So this is the next thing you're going to look into. So basically this is a variation of the first problem that you saw. There is an electron transfer happening with but apart from that there is an electron adsorption reaction that's happening. Basically some kind of another impurity or an adsorbent is present which will be hindering the active site for your desired reaction. Okay, so if I am writing it, I can write it in the form of P solution giving K1. Okay, it's rate constant this much. So it directly goes into the solution. And an electron transfer is involved in this step. Okay. Now, so this is the variation of the first reaction mechanism you had seen where of ferroferricyanide. So here now that step is involved. Now apart from that, there will be some kind of something absorbing into the metal surface. So if I am writing that, I can say yeah. So there is something going into the solution. Okay. Okay, and something is get from the solution, it's getting absorbed on the surface. Okay, and hindering the active sites for for the actual reaction. So what does that mean? So if you see, both are electrochemical reactions. Okay, now what is happening? This one is our desired reaction. Okay, this one is our desired reaction. Now what is the impurity that is present? This from the solution, something comes and adsorbs onto the surface of the electrode, and thereby what it does, it is hindering the active sites that are available for our desired reaction. So basically the active sites that are, so if you remember in the last class, the first reaction we saw, the first reaction mechanism we saw, there are no, that's like a simple step reaction. So even if you see here, it's a simple step. Something is directly, like A is directly getting transformed to B. We had seen the last class, that reaction. A is directly getting transformed to B. But here what is happening? Is the entire surface available for that reaction? No. Something from the solution is getting deposited on the surface of the electrode, and thereby it reduces the total number of active sites. Okay, so yeah, so the only difference that will come over here is unlike the first one, the first time when we saw here, there will be a site balance also involved. Why site balance? Because of this A adsorb that is getting formed. So if you see, some ions from the solution is getting reduced onto the surface of the electrode. So if I am saying that theta is the active site of A adsorbed is occupying theta sites on the electrode surface. So now my question is, what is the reaction for the forward reaction of reaction 2? Can anyone tell? Can anyone tell? Now you have to write, you have to know what is, okay, first R1, you know what is R1, you should know what is R2, and you should know what is R minus 2. So if you see, theta are the sites associated with the A adsorb. So you can directly tell what is the reaction rate for the backward reaction. Backward reaction in the sense A adsorb giving A solution. What should it be? It will be nothing but K minus 2 into the theta, because those many sites are what are involved with A adsorb. Now what will happen to the forward reaction? Forward reaction will be nothing but K2 into A solution A solution minus. Is it enough? Only this much? Where is it getting reduced to A adsorb? Is it able to get what to say, reduced to A adsorb, like A solution? Is it able to get transformed into A adsorb over the entire surface of the electrode?
will it be into 1 minus theta?
Yes, 1 minus theta. Why? Because the entire surface is not available for the A solution to get transformed into A adsorb. Okay. Now what will be the for the first reaction? That will be nothing but K1 into P solution. Same way. Only those sites where A adsorb is not there will be where what to say PA solution can get transformed to Q solution only in the places where A is not getting absorbed. So which corresponds to 1 minus theta. Is this step clear?
And in this first step, is fraction of the surface is involved because it is from solution to solution.
Yeah, why is it involved? Why is it involved? Because here there is some reaction which is happening on the electrode surface. Okay, that is P solution. Something from the solution is getting reduced to something else, again falling onto the solution, but it's happening on the electrode surface, right? Is it able to happen on the entire electrode surface? Is the entire electrode surface available for that reaction? Yes or no? See something, okay, from something is present in the solution. What is this electrode doing? It is providing a surface for that to get converted to something else. A is getting converted to B. Okay, A is getting converted to B on the surface of the electrode. Okay, but is the entire surface of the electrode available for that?
Yes.
Is it?
No, part of
Because
it is available.
a part of it is available. Why? Because A is getting adsorbed on the surface. So A is getting adsorbed only on the theta surfaces. So the rest of the surface, that is 1 minus theta, is only available for the first reaction to happen. Is that clear? Okay. So now the next thing is to write the theta balance. Please try it out. How will the theta balance come? Who can tell what is the theta balance? Theta balance corresponds to those which involves the adsorption happening of the A adsorb. So that means only this reaction will be, the second reaction will be corresponding to theta balance, theta in the theta balance which you write. So which will be nothing but will be gamma d theta by dt equal to K2 A solution minus 1 minus theta minus K minus 2, because in the second, if it is a backward reaction, it is the A adsorb that is getting consumed. adsorbed. Sorry. So adsorbed is an intermediate. So I should write it as minus K2 into theta. Is there any doubt in that? Now who can tell me what is, see we are already doing this multiple times. So now I am asking someone, please tell me what will be the steady state theta value. Who can tell me what is theta SS value? That will be nothing but, I have to just equate this to 0 and it will be K2 dc Is this correct? Is everyone getting? Is this correct? Is anyone trying it out? So okay, so the next one is to find out the Faraday current. So who can tell me which all reaction rates will be involved? So the first one it will be positive, the next one will be again R1 plus R2 minus backward reaction, right?
Right.
Now, so please substitute and tell me what is IFDC. I'll give you 1 minute. Please try. See, only if you try to do it yourself, it will be easy for you. So, what is the IFDC? It will be F into, so the first reaction is nothing but K1 into P solution into 1 minus theta. Next step will be K2 to A solution minus 1 minus theta minus K minus 2. So because it is DC, you can substitute the steady state value over here, right? Is this correct? So now the
Yes.
next step is you will have to substitute the theta SS value in this and simplify. This is up to you. Okay. So for the assignments, mostly the K1 DC, K2 DC, all the values will be given. Steady state, you will have to substitute those values, find out theta SS, again back substitute in IFDC, you have to find out the numerical value. So that those kind of questions is what you will be expected to solve in your assignments and even for your exam. Okay, so this is about IFDC. Now, how about IFAC? How will it be for IFAC? So, IFAC is, so you have to find out IFAC. So, for that, what you will do? You have to find out the total Faraday current, right? So, what is IF total? Sorry. So, for IF total, what you'll do? You'll be using the same equation, but provided, I mean, same equation where you will be substituting K1 as K1 DC into 1 plus B1 EAC, K2 DC will be K2 DC into 1 plus B2 EAC, K of the backward reaction, K negative 2 or backward reaction step, for the second step it will be K negative 2 DC, negative just means it's a backward step, so into 1 plus you will write subscript minus 2 DC into 1 plus I mean 1 plus B minus 2 EAC. Okay. Again, theta will be nothing but theta SS plus theta dash EAC. I can give you few minutes. Please try doing it. So in case you have any doubt, I'll then write down the final answer. I can give you 3 to 4 minutes. Please try doing it. Anyone has any doubt, you can ask me.
So K1, what we have to write?
You have to find out IF total. How will you simplify? From that, you have to find out IFAC. So for this equation, that is this equation, you will be using where you will be making substitution for K1, K2, K minus 2. And again for theta will be nothing but theta SS plus theta dash EAC. Make all those substitution and find out what is IFAC. So I can give you some hint in drawing. So it will be nothing but, so please start doing. I won't do the entire thing because we run out of time and we won't be able to solve. Then we'll be stuck with this question for the entire class. So if you do this, you will get something IF total. Okay, will be something of the form F into K1 DC into 1 plus D1 ASC into P solution into 1 minus theta dash AC minus theta SS. So this will be the first step, okay? And the next one will be plus K2 DC plus B2 EC Is this correct? Now you have to simplify it. Simplify in the sense you have to open the brackets and differentiate between IFAC and IFDC. Please do it. This is how the equation should look like. So if you are simplifying it, okay, you're supposed to get, I hope everyone is trying out. Okay, only if you try out, you'll be able to solve these questions. I've already, if I am going to show you the entire derivation, it will take the entire class. We won't be able to discuss much. So I'm just skipping. So we have already done around 4 or 5 questions to see how we simplify it. So I'm directly going to the answer. Okay. If you have any doubt, you can ask me for sure. So your answer should be something of this form. If you need some more time to solve it, please let me know. I hope everyone is trying this out. Okay. Is there any doubt in what I'm writing? So everything into ESC. Are you able to get something of this form? Are you trying it out? Hmm? Anyone has any doubt? Okay, so the next step is to find out theta dash. So that again, you'll have to go back to this balance equation. You have to substitute for theta as theta ss plus theta dash EAC, and again K2 will be K2 DC into 1 plus B2 DC EAC, K minus 2 will be K minus 2 DC into 1 plus B minus 2 EAC. You can substitute it, and d theta by this dT will be j omega theta dash EAC. Substitute it, cancel off all those terms where EAC square comes and constants alone, segregate the terms with EAC and substitute, find out theta dash. So once you find out theta dash, you can substitute back in this equation. That will be your, final equation. Okay, now if you see, I have segregated it into two things. So in this part, there are no constants involved, right? There are no constants involved, and here because theta dash is coming, you will have something which is a function of omega. So yeah, so that is what the equation will be finally. And now if I am giving you the final equation, I will write down the final equation, you can try it out. Okay, so it's going to be a little lengthy equation, but I'll write it down. Please try it. If you have any doubt or you're not able to get this, we'll discuss it in the next class. Okay, I would like to discuss one more question on like how will you solve it if two reaction intermediates are involved. So for that, if I'm solving this question, it will take the entire class, which I'm not interested. Okay. Okay. And you will have the term due to theta dash, which will be nothing but will be B2 minus B minus 2 B minus 2 into K2 DC into K2 DC into K2 DC. So please try that out because the derivation is lengthy. I'm not showing the entire step. Okay, we'll go on with the next problem. Okay. You have a solution. So please try this out, and we'll if anyone has any doubt in the step, we'll try it in the next class. you'll have another term where it will be minus K2 dc plus j omega gamma. So this last term, that is this b2 minus b minus 2, this is coming, that entire term is coming from the theta dash. So if you solve that first theta balance equation, you will get that. Okay, so this is for this problem where you will have two types of impedance. I mean, it can either go to the positive plane, or I mean it can stay in the positive plane, or it can go to the negative plane during the low frequency. So that is dependent upon the I versus E value. So if you remember, if your differential of di by de is positive, then your impedance will also be positive in the low frequency regime. But in case if it is in this region, that is your applied potential goes to the be in that region where de by di goes to the negative side, then your impedance will be negative. Okay, so this was the example for that. Okay, now we'll move on to the
As a, excuse me, it is considered as
yes,
a
tell me.
polarization resistance.
Sorry.
If it is negative slope,
Hmm.
in that case it is considered as a polarization resistance.
I didn't get you. So basically, in this reaction mechanism, your impedance depends upon the differential impedance. It depends upon this dE by di. So in case, so if your E value is such that, I mean, if after this point any value of the potential are in this region, you can see that di by de will be a negative value. So in that case, your impedance will go to the negative plane at the low frequency regime. You can expect something like any shape, but I'm just telling something like this. If you remember Searle's class, it was something of this form that he had shown. In the same case, if the potential is in this regime, if you actually try to code this and plot it, you will get something, it will be in the positive side. So that's what I was trying to convey.
But
So you
in
were,
this case, what will be polarization resistance? Suppose if it is a negative slope and positive slope, then what is the polarization resistance?
see, polarization resistance depends upon, so at omega tends to, what is the polarization it is at omega tends to infinity, right? No, it's, yeah. So if you find out this equation and you give that value for omega, what you get, the leftover will give you the polarization resistance. Okay, that's different. So here basically you are trying to, so any case you are supposed to find out this equation, and then if you want polarization resistance or anything, you have to give that condition. I mean, if it's charge transfer, it will be omega tends to 0 or anything of that kind. Substitute it, find out the value. You can predict the for such a mechanism if the impedance will be in the positive plane or in the negative plane, depending upon what is your differential impedance. Okay. So, okay, we'll try to solve one more problem for this class. So, that is going to be two-step absorbent. Okay. So, you have two adsorbed intermediates involved. So, unlike the first problem which we saw today, where only one adsorbed intermediate was involved, see the steps remain the same. The only difference is you will have different equation for each intermediate in the sense on the side balance. So if you have two intermediates, you'll have two side balance. If you have more than that, you'll have more intermediates. So I'll write the question. M gives M adsorb plus, so it forms first M adsorb plus plus the electron, and in the second step, this M adsorb forms. So you can try out numerous kind, like with small differences. There can be case where, okay, first let me write this problem. And that's up 2 plus, okay, plus electron. And in the next step, so this 2 plus goes into the solution. The second intermediate is directly going into the solution. Okay. Solution 3 plus. So here basically the question which I'm going to discuss, all the three steps are electrochemical step. So in case you want to try out something, in the sense you want to try another variant of this, you can go for some case where M adsorb 2 plus directly becomes M solution 2 plus. It's going directly into solution and no electron transfer is involving. So instead of this, I can also go for purpose of just trying out questions, you can also try this kind. So here no electron transfer will be involved. Sorry. So you can even try out a variety of this kind, or you can make any of the steps as reversible, and again you can try out. So the mechanism which I am going to discuss for today's class is this one. Or if time permits for the next class or something, I can show you different varieties. So we'll try this one now. So okay, so the first step is to identify the electrochemical and the chemical step. So in all these three reactions, you can see electron transfer is happening. So all the three reactions will be will be responsible for the current. Okay, you cannot omit any of the steps. So that's the first thing to identify. Next thing, to see how many reaction intermediates are involved. So you can see it is M-adsorb plus and M-adsorb 2 plus are the two reaction intermediates involved. So when you are writing the reaction step, you should take into consideration theta 1 and theta 2. Okay. So who can tell me how will you do the site balance for M-adsorb plus? So I'm just writing the sites occupied by M-adsorb plus is theta 1. So who can tell me the site balance for M-adsorb plus? So which are the steps which are involved in um, the formation of M-adsorb plus and the consumption of M-adsorb species? So you can see in the first step, this one, M-adsorb plus is getting formed. So it will be nothing but K1 into, so yeah, so if M-adsorb plus, okay, occupies theta 1 site, okay, M-adsorb 2 occupies theta 2 site, what is the free vacancy sites available on the surface of the electrode?
1 minus theta 1 minus theta 2.
Yes, correct. It's 1 minus theta 1 minus theta 2. So if there were one more species, could be something like 1 minus theta 1 minus theta 2 minus theta 3. So when number of equations increases, you will be basically using any software to solve the equation simultaneously. Sorry, so it's theta 2. So so first step is, okay, you know what is the fraction of free sites also available. So tell me what is the site balance for M-adsorb plus. So if total number of sites are gamma, d theta 1 by dt will be nothing but Which are the reactions involved? So in the first step, MHOP plus is forming, and the second step MHOP plus is getting consumed. So you can see in third step there is nothing with MHOP plus. You only the first two steps are involved. So you can see what is the rate of the first step. Because theta 1 is getting formed in the first step. Okay. So that's why it will be positive, and the next step you can see that it is getting consumed. So it will be minus K2 into theta 1. Correct? Now anyone please tell me what will it be for side balance for theta 2, I mean for MH of 2 plus species.
In the first equation, you have written minus K2 theta 1. So when it comes plus K2 theta 1.
Okay, so you see, what are you doing here? You are doing the side balance for the first species, right? That is MH of plus. Okay, so where basically, even in chemical engineering, when you are forming something, your generation rate of generation is positive, and rate of consumption is negative, right? When you're writing any mass balance equation or anything, rate of formation is positive, rate of consumption is negative. So same thing applies here. MHR plus is getting formed in the first step, right? So I will assign it positive. While in the second step, it is that MHR which is getting consumed. So I'm writing minus K2 theta, correct? So please tell me how will it go for MHR 2 plus species. I hope then your doubt will be clear.
Yes.
So what's happening in the reaction 2, the step 2? You can see MH of 2 plus is getting formed, right? So you will have something K2. So you can see it is the concentration of MH of plus, so which is occupying theta 1 site. So K2 into theta 1. While in the next step, if you see, it is that MH of 2 plus getting into the solution. It's for getting into the solution. So MH of 2 plus is getting consumed. So I can write this minus K3 into theta 2. Is your doubt clear?
Yes.
Okay. So yeah, so you found out. So here you are having two equations. If you solve it, so now you have to find out what is theta 1 at steady state and theta 2 at steady state. So what can be done? As we had done previously, you will have to equate both to 0. You have to find out both two equations and try to express one in term of the other. In the sense, if you solve this, okay, you will get an equation of theta 1 in terms of theta 2. So basically, if I say it will be K2 dc into theta 1 ss equal to K3 dc into theta 2 ss. Top also you will get an equation which will have theta 1 ss on one side, theta 2 ss on the other side. So take one, put it in the other, find out separate equation for theta 1 ss and theta 2 ss. Please start doing. Any doubt in what you have to do? I'll give you a couple of minutes and then I'll discuss the solution. Are you able to get? So at steady state, we'll get two equations. So first one will be something of the form if I solve the first equation, I should get something of this form. Just equate it to 0 and rearrange. Hmm. Are you able to get this? Now again, if you rearrange this, equating it to 0, you're supposed to get something of this form. Okay? Now what you can do? Both are in terms of theta and SS. You equate both of them. You're supposed to get an equation for theta 1 SS and theta 2 SS. Anyone got an equation? So if you equate it, you're supposed to get something of this form. Okay? And for theta 2 SS, are you able to get this? Anyone? Now theta 2 SS. So basically all these are max. Just I mean rearranging it. Once you get the first equation, then it's all about rearranging it and finding it out. Are you able to get this? Now what is the next step? We have to find out IFDC. Who can tell me what is the formula for the Faraday current? Which all reactions will be involved? You have all the three reactions involved, right? Because all the three are electrochemical reactions. So your equation would be nothing but F into R1 plus R2 plus R3. So we have already written down what is R1, R2, R3. Someone's mic is on. Could you please off it because echo is coming? Or if you're having any doubt, you can ask me. Okay. So you have to substitute. And finally, what we have already found out the equation for theta 1 SS and theta 2 SS. So you have to substitute it in the equation and find out what is IFDC. Similarly for IFAC, the next step is to find out IFAC. Can someone start doing, can people start doing? I'll also meanwhile write. If anyone has already done this, you can tell me. Or if you have any doubt also, please ask me. Are you able to do this? So this is the equation for IF total, okay, not IFAC. I'm just expanding the total Faraday current equation, okay. Is this clear? So now the steps are the same. You have to expand it, find out IFAC, find out theta dash. So here the tricky part is you will have two theta dash. One is theta 1 dash and next is theta 2 dash. So you have to substitute in both the equations separately and find out theta 1 dash and theta 2 dash. And substitute it back into the equation and you will get the equation. Okay, I'm not doing that part. I hope you get what I'm saying. So you'll have theta 1 dash. If you solve this, so if you see here, you'll have theta 1 dash and theta 2 dash also. So how to find out? You can go for the side balance equation. You have two side balance equation. substitute that, I mean, for that again, you know how to do. Dou theta 1 by d theta is d theta 1 by d theta is nothing but j omega gamma theta 1 dash. Again, d theta 2 by dt is nothing but j omega gamma theta 2 dash. Substitute it, cancel off all the constant terms and the EAC square terms, equate the terms, segregate the terms having EAC in it, and once you rearrange it, you will get equation for theta 1 dash and theta 2 dash. If you substitute it, you will get the final equation for IFAC. If you have any doubt, we can then discuss it in the next class. So I'll just write down one more equation which we will discuss in the next class. Please try this out. Okay. So the steps are the same. The only difference is in the. So unlike the previous example which we saw, where all the equations were irreversible, here I am writing my steps are reversible here. So here the only difference will be in the side balance equation and the IF equation. Then it's all about solving. Second step is also a reversible step where M adsorb 2 plus is formed. And the only difference is, unlike the first case which we saw, where all the three steps were electrochemical step, here I am saying M adsorb 2 plus directly forms M solution 2 plus. That means it's not an electrochemical step. So what all will be the differences here? So when you're writing the theta balances, it will be similar to the last case, except that the steps involved here are reversible in nature. Okay, so that's the first thing you have to take into consideration, and the next thing is in the finding the IF. You can see only these two steps have the electrons involved, so that will be only contributing to the current. Okay, so once you do this, we'll discuss this in the next class. Anyone has any doubt in what's taught today?
In this, how many intermediate species are present? Just now you explained.
How many?
Intermediate species are present.
So you can see here, it's MHOP plus is formed in the first step, and then the next reaction, MHOP plus is getting converted to MHOP 2 plus. So there are two intermediates. This one, the M solution 2 plus, that's directly going on to the into the solution. So what intermediates means are the ones which are present on the surface.
Those which are present on the surface, that is.
Any other doubt?
So, Sri Lakshmi, could we do one numerical solution regarding this theta SS or any Faraday?
I didn't
Because in
get
the
you.
last assignment also we found some numericals.
Okay.
So, can we take one example, any numerical solution, how we have to solve that?
Okay,
And
numerical, so okay, so if I can tell you
because
now.
in the book also I download the book, Sir book that written by the Sir. So in that also I didn't find any numerical how we have to solve.
See, how we
So
have to solve the numerical problem in the sense. So if you found out the theta SS value, let me take the example of this one also. If you see here,
yes,
theta 2
yes.
SS is 1 by K3 DC into 1 by K2 DC plus K3 DC plus K1 DC. So obviously in the question, the values of K3 DC, K2 DC and K1 DC will be given.
No, it's a given B1 also given that and K11 K10 also given. Then e raised to the power K
Yeah, you
B
have to
into
use
E.
that equation. So K3 DC will be nothing but B3 into e to the power EDC.
And for the negative minus B1, so we have to take the B raised to minus negative.
Yeah, that's it.
Okay. So then we have to calculate K1 DC and K2, K3.
Yeah, yeah. Then you substitute in this equation.
So that's why I need your help if we can solve any numerical.
Okay, for the next class, I'll make some numerical problems based on this, and
Any
I'll solve.
random value we can take and we can solve that. What
Yeah,
will be the
sure.
process?
Yeah, I'll do that then.
Okay, thanks.
Any other suggestions? Okay, we'll discuss that in the next class, sure. Any other suggestions? Okay.
Whatever the assignment which are over,
Mm,
suppose assignment 5 is over now.
mm.
So if you can solve certain numericals which are there, then it would be helpful to us to understand, because they have given us answer directly, but how step by step, that we actually I don't know.
Okay,
Like
I'll
last
dis
time,
okay,
question of
I'll
assignment 5,
okay.
which is already
Uh,
over, the due date is over, and we have submitted them.
okay. Okay, I'll discuss that with sir and then let you know. Okay, if I'm allowed to do the problems which are given in the assignment. If I'm able to solve, if I'm allowed to solve, I'll do that. I'll make a provision for that. I'll talk with the sir who is taking this course, and then I'll let you know. Okay?
Means I
Okay.
am telling those which are already solved, means already submitted assignment, means
Yeah, I
no,
understand that.
yesterday's, last week's.
Yeah, I understand that. I'll ask sir and let you know. Okay?
Okay.
Yeah. Or we
Yeah.
can take some similar examples.
Okay. Similar examples are possible. That
Mhm.
I'll make a way for that.
Sure.
Okay. Okay, then that's all for today. We'll then meet in the next class. Thank you.
Yeah.
Hello.
Thanks.
Yeah, tell me.
Lakshmi, I have one small doubt. This is
Yeah, tell me.
regarding the charge transfer and polarization. It's not related to like for the recent week and all.
Yeah.
See, when we say our reactions are kinetics limited,
Hmm.
and then we are for the Faraday impedance, we say
Hmm.
there is a charge transfer resistance and there is a polarization resistance, right?
Hmm.
What is the physical significance of it actually?
So we are trying to find out the impedance when at what the impedance at low frequency regime and the high frequency regime. So when the omega tends to a very large value, what is the resistance? That is what is termed as the polarization resistance.
That is
Similarly,
what the math. That is what is the mathematically we are doing. But for a reaction system, what does it represents actually?
what does that represent actually in the sense?
See, like when we say that there is a charge resistance,
Hmm.
charge transfer resistance, and then there is a uh, polarization resistance.
Okay,
So
I'll look
polarization,
into that and let you know for the next class if that's okay for you.
yeah, fine, that is okay.
Okay, I'll check that and tell you next class.
Okay. Else I can put it in the group.
Okay. Okay. Anyway, I'll do that.
Okay, thank
Okay.
you.
Yeah, thank you.
Okay.
Anything else? Okay. If nothing, then we'll stop for today. We'll meet next class. Thank you. Good night.